So this is just the last part of section P2. And I'll do each of these problems two ways, which is generally not the best thing, but you can pick the way that you want. So in problem 66, I can reduce the fraction 40 over 10 and kind of keep that separate in my mind from the z's. And I could subtract the exponents on the z's and do 2 minus 6. This is the proper way to do it. 40 over 10 reduces to 4. So when I go to write my answer, I can think of this as 4 for the fraction. And for the exponent, z to the 2 minus 6 gives me z to the negative 4. Then I would have to think of this as 4 over 1 times z to the negative 4. Use the rule to make the exponent positive. This is 4 over 1 times 1 over z to the 4th. Then multiply the 4 and the 1 and get 4. Multiply the 1 and the z to the 4th and get z to the 4th. This is the proper way to do it. It introduces a negative exponent, but it's perfectly correct answer, and this is the proper way to do it. The lazy way to do it would be this. 40 over 10 reduces to 4. That 4 belongs in the numerator because the bigger number, is in the numerator. I look at the letters. Bigger exponents in the denominator. I can avoid negative exponents if I leave the letter in the denominator and do big exponent minus small exponent. And this is going to give me the 40 over 10, which is 4 in the numerator, and 6 minus 2 is 4 in the denominator. Both the same answers, one the proper way, one a lazy shortcutting way. The lazy shortcutting way is infinitely better than the proper way, but both ways will work. I'll do both ways for these next few problems, and you can pick the way that you want. Proper way, introducing negative exponents. Non-proper way, not introducing negative exponents. So I'll do 68 proper. So at 68, I need to really think of it as two separate problems if I'm doing it properly. Think of it as x squared over x to the 4th and y to the 5th over y to the 1st. I'm going to subtract the exponents and won't get a fraction using this strategy. So it's going to be x to the 2 minus 4 times y to the 5 minus 1. When I'm subtracting the exponents, it gets rid of the fraction. The x to the 2 minus 4 is x to the negative 2. X to the y to the 5 minus 1 is y to the 4th. The x to the negative 2, I can make a fraction, make it 1 over x squared. The y to the 4th, I can make it a fraction, make it y to the 4th over 1. Now I'm going to multiply across the numerator. 1 times y to the 4th is y to the 4th. Multiply across the denominator. X squared times 1 is x squared. That's the proper way to do the problem. It uses the rules exactly how they're intended to be used. If I was doing this problem, although this way is correct, I think it's hard. I'm going to treat these as two separate problems. I look at the x's. For the x's, the bigger exponent is in the numerator, so the x is ultimately going to, the bigger exponent's in the denominator, the x is going to wind up in the denominator, and I just do big exponent minus small exponent, leave the letter where it belongs. The y, the bigger exponent is the numerator, the y is ultimately going to end up in the numerator. I'm going to do big exponent, 5, minus small exponent, 1, leave the letter where the bigger exponent is. So the x winds up in the denominator because the bigger exponent's in the denominator. The y winds up in the numerator because the bigger exponent's in the numerator. And here I get the same y to the 4th over x squared way quicker. This is usually the way I teach. This is the proper way. Some students just want to do the proper way. So I'll deal with 70 the same way. Do it the proper way, do it the shortcut way. These are two separate ways. You decide what you like. The proper way for 70 is to think of x cubed and x to the 5th kind of separately from y to the 5th and y cubed. I'm going to simplify the x's properly by subtracting. Do x to the 3 minus 5. For the y's, properly by subtracting y to the 5 minus 3. This introduces a negative exponent. It gives me x to the negative 2 y squared. Can make the negative exponent positive. X to the negative 2 is 1 over x squared. I can make the y squared a fraction, make it y squared over 1. Now I'm going to multiply 1 times y squared and get y squared. I'm going to multiply x squared times 1 and get x squared. My answer is just going to be x squared over y squared. That's the long way to do it. The proper way it introduces negative exponents. The shortcut method, I look at the x's. The bigger exponent of the x is in the denominator. To simplify, I do big exponent minus small exponent and leave the letter where the bigger exponent is. That's case it's in the denominator. I look at the y's. The bigger exponent for the y is in the numerator. I do big exponent minus small exponent. Leave the y in the numerator because that's where the bigger exponent is. Get the same answer. This is the shortcut method. The shortcut method of reducing fractions that could introduce negative exponents is avoid the negative exponents. Instead of using the rules for subtracting the exponents and then introducing a negative exponent, taking the time to make the negative exponent positive, learn the shortcut. If there's a fraction and you have to subtract exponents, you don't need to introduce negative exponents. Just do big exponent minus small exponent, leave the letter where the big exponent is. I'm going to do the shortcut way only for 72 because I think it's better. So first I'm going to reduce the fraction 6 over 30. On my calculator, 6 over 30 reduces to 1/5. The 5 I'm definitely going to need in the denominator. The 1 I don't probably need to write in the numerator. I would only write the 1 in the numerator if there's nothing else to be put in the numerator. Now I'm going to attack the x's. The x's have an exponent of 2 and 9. I could do x to the 2 minus 9 power, get x to the negative 7, make that 1 over x to the 7. That kind of shows me the x is going to wind up in the denominator. That's inefficient. When I'm dealing with letters, I just look at the exponents. I do big exponent minus small exponent, leave the letter where the bigger exponent is. Here, the x's bigger exponent's in the denominator. The x is going to wind up in the denominator. For the y's, the exponents are 3 and 1. The bigger exponent's in the numerator. The y is going to wind up in the numerator because of that implied exponent 1. So for my answer, I'm going to get y squared over 5x to the 7th. I find that infinitely superior than this method here. That's the proper method. Proper is nice, but I think it's more work, and this is not a lot to remember. It's a deviation. It's not using the rule properly. It's using a shortcut that will work every time. This is the rule tells me the proper way to get the answer, but sometimes I can develop shortcuts, and this is a lovely shortcut. If you're dividing with letters, there isn't any adding or subtracting between the letters or variables. You do big exponent minus small exponent, leave the letter where the bigger exponent is. In 68, the x winded up in the denominator because the bigger exponent 4 was in the denominator, and the y wound up in the numerator because the bigger exponent was in the numerator. Just a bunch more of these. I'm going to shortcut all of these. So for problem 74, I'm going to reduce the fraction 20 over 18. 20 over 18 reduces to 10 over 9. You can reduce this by hand by dividing by 2. Now for the x's, I examine my x's, the bigger exponents in the denominator. I do big exponent minus small exponent, leave the letter where the bigger exponent is. Similarly for the y's, bigger exponent is in the denominator, big exponent minus small exponent, leave the letter where the bigger exponent is. This is getting my answer written with positive exponents, which is generally required. So numerator just has a 10. The denominator has a 9. The x winds up having an exponent of 4. The y winds up having an exponent of 1. I don't need to write that one. Alrighty, for 76, I'm going to reduce the fraction 4 over 24. That reduces to 1/6. Usually I won't write the 1 part in the numerator unless there isn't anything from the algebra that goes in the numerator. If nothing winds up in the numerator, then I'm going to put a 1 behind. But in this case, there's going to be stuff in the numerator. Now I'm going to move to the x's. The x's, the bigger exponent's in the numerator, so I'm going to do big exponent minus small exponent, leave the letter where it belongs. The y's just cancel. I won't worry about those. For the z's, the bigger exponent's in the denominator. I'm going to do big exponent minus small exponent. Again, this is a shortcut that avoids negative exponents. I prefer this shortcut. My answer now, in the numerator, I'm going to get an x cubed. In the denominator, I get a 6z to the first power, and I don't need to write that 1. So x cubed over 6z would be perfect. Last problem. Reduce the fraction 36 over 24. Reduces to 3 over 2. I could divide by 12 to reduce that. So I'm going to get a 3 in the numerator, a 2 in the denominator. I move on to the x. For the x, the 10 is bigger than 4. I'm going to do x to the 10 minus 4. For the y, the 7 is bigger than 3. I do big minus small, leave the letter where the bigger exponent is. For the z, I'm going to do 4 minus 2, big exponent minus small exponent, shortcut the negative exponents, leave the letter where the bigger exponent is. And then for my answer, in the numerator, I have the 3 from the reducing of the fraction, x to the 6th, y to the 4th for subtracting the exponents, and then the denominator, I get a 2z squared. That's all this section. That's all we need to do is perfect these problems. There are more negative exponent problems in the world that are maybe slightly more complicated than what we've done. But for now, this is, I don't want to plunge into off the deep end. And there's not a lot of negative exponent work in college algebra, so this should really prepare you well for college algebra. I'm going to pause the video and we'll move on to section P3.